In this video, we're going to talk about special cases of indices. Right, so when we write 7 to the power of 2 or 7 squared, we know that it's going to be 7 times 7, right? And if we go with, well, let me have this a little bit here. If we go before that 7 cubed or 7 to the power of 3, it's 7 times 7 times 7. So basically, if it is 7 cubed, which is 7 times 7 times 7, 7 squared, which is 7 times 7, then 7 to the power of 1 will be just 7. Because if it is cubed, then there are 3 sevens. If it is squared, then there are 2 sevens. So if it is 1, then it's only 1 7. So basically, all these numbers that we write, like, 5 or 21, these numbers are actually 5 to the power of 1, 21 to the power of 1. We just don't write them because we don't need to, okay? So by default, it's their first power, right? So 7 means 7 to the power of 1, as 7 to the power of 1 means 7, right? Another thing, how about 7 to the power of 0, right? So basically, we have to discuss this by using a definition. Okay, let's look at this case. Now, let's get rid of all this and then write down 7 to the power of 0. Now, if I use the division law, right, I can, for example, write this as 7 to the power of 3 minus 3, because 3 minus 3 gives me 0, right? But 3 minus 3 means that I can write this as 7 to the power of 3 divided by 7 to the power of 3, right? When it is a division between index numbers, then the division law tells me that I have to take away the powers from one another, and that's what happens. So it's 7 to the power of 0 still. But if I write this as a fraction, like 7 to the power of 3 over 7 to the power of 3, right? I mean, I can see from here that it is going to be 1 because you're dividing a number by itself, right? So it must be 1. However, let me go on with the definition. So 7 cubed, 7 to the power of 3, means 7 times 7 times 7. And 7 times 7 times 7 here in the denominator 2. And what happens is, you can just simplify them. So when you simplify everything, 7 divided by 7 is 1, 7 divided by 7 is 1, and 7 divided by 7 is 1. These are all in multiplication, so you're going to end up with 1. Or, if this is confusing for you, you can say that 7 cubed, or 7 to the power of 3 is 343, but it's the same number here, and again, the idea is if you divide a number by itself, you get 1. So basically, if this is true for 7 to the power of 0, it is always true for any number, so a to the power of 0 will always be 1. Regardless of a. Now, I can't accept a to be 0 though, because you cannot divide 0 by 0, so that's another case. But generally speaking, if this number is a non-zero number, right, to the power of 0 means it's going to be 1. Another case is that if you have, let's say, 3 to the power of negative 1 as a negative power, this means that you have to write a fraction, 1 over 3 to the power of 1, or basically it's going to be 1 over 3. Or if you have 5 to the power of negative 2, then it is going to be 1 over 5 to the power of 2, or 5 squared. So you can remember this special case as, if you consider this as a fraction, 3 to the power of negative 1 over 1, what you do is you flip it. You just flip it upside down. When you do that, you lose the sign. Yeah? So this sign disappears here. this sign disappears here when you write it like this. Yeah, you flip it, you write 1 to the top, 5 squared to the bottom. So this is how you deal with negative powers if need be. Now, these are called as reciprocals or multiplicative inverse, because if you multiply, let's say 3 squared by 3 to the negative 2, right? It's reciprocal actually. What happens is, according to the multiplication law, it's going to be 2 plus minus 2, which is basically 2 minus 2, right? This is a minus. So you end up with 3 to the power of 0, which means 1. So if you multiply two numbers and end up with 1, then you say that these numbers are reciprocals for each other. They are multiplicative inverses. Right? That's another story. But what you need to know is that you can just change a negative power like 7 to the negative 3 like a fraction, 1 over 7 cubed. Now is your turn. Please solve these questions on your book and submit your answers online. Thank you.